Hey, what's up everyone? In the previous videos in this series, we saw how to solve 2-sum, 3-sum, 4-sum problems. Today we will see how to write a generic solution that works for any sum. For example, 2-sum, 3-sum, 4-sum or 7-sum. Unfortunately, this problem is not available on LeetCode and hence I have created a new problem on Hackerrank called n-sum. The problem statement is exactly same as 3-sum or 4-sum, except that instead of 2, 3 or 4, we have a generic k which we will take as input, and rest of the problem statement remains the same. Hey, Bhavesh here, and on this channel we learn and apply various data structures, algorithms to solve interesting programming questions. So if this is your first time on this channel, consider subscribing. Let's take a look at problem statement quickly. We want to find all ways of selecting k integers from the array nums such that they add up to the target. And instead of returning the entire list of all the different ways, we just need to return the count of number of ways. So if we take a look at this example 1, 1, 2, 2, 2, if k is 2, that is we want to choose two numbers that add up to the target, that is 3. So there is only one way, that is choosing 1 and 2. Now there are multiple 1s and multiple 2s, but the unique ways are only one, that is choosing 1 out of these two and 1 2 out of these three. Before starting to code this solution, let's take a look at the approach that we will take. Let's say the input array is this from 1 to 9, and if k is equal to 2, then we already know how to solve this problem, and we have already written the method 2sum that will take care of this. Now if the k is 3, then we again know how to solve this problem by using the 3sum, and in the 3sum method we fix one number at a time and solve the 2sum problem in the rest of the array. Similarly, for 4sum problem, we fix one number at a time and solve the 3sum problem in the rest of the array. So if we are to generalize this solution, if let's say k is 5, then we will simply fix one number at a time and solve the 4-sum problem in the rest of the array. Now if we want to find the generic solution, we will use the same approach, that is by fixing one number at a time and solving k-1 sum problem in the rest of the array. Now thinking about the actual coding, we wrote a 3sum method which had a for loop, and in the for loop we used to call the 2sum method. Similarly, for 4sum method, we wrote a for loop which will call the 3sum method, which will in turn call the 2sum method. But now we want to generalize this solution, and without knowing what the k is, how can we write the code that will generate these 4sum, 3sum method and so on? By now you must have already guessed, the idea is to use the recursion. In the recursion, we will solve the k-sum problem using k-1 sum problem by fixing one number at a time and calling the same method with k-1 as input parameter. As we already know how to solve the 2sum method, that will act as our base case. In the other cases, when k is not 2, that is base condition is not satisfied, we can simply write one for loop which will fix one number at a time and make recursive calls. Before actually coding the solution, let's also discuss the time complexity that our solution will have. So for k equal to 2, we already know that we can solve this problem in linear time, that is big O n. So for k equal to 2, the time complexity is going to be big O n. For k equal to 3, we are going to fix one number at a time, and there are n such numbers, and n times we are going to solve the 2sum problem, that is big O n, and hence the time complexity of this solution will be big O n squared. For 4sum problem, we are going to solve 3sum problem n number of times, and hence the time complexity is going to be big O of n cube. And hence, to generalize the time complexity further, for any k, the time complexity will of course be n power k minus 1. Here we are going to implement this find n-sum method. As discussed earlier, we are going to use the 2sum method as a base condition, so I will copy that from one of our previous videos. So I have copied these three methods from the 3sum video. If you haven't watched that video and don't know about these methods and how they are implemented, I would highly recommend you to watch that video so you get the complete understanding. Just to summarize a little, the increment method and decrement method are written to skip the duplicates in the array. The 2sum method takes the array as input and the start and end indices between which we want to find two numbers that add up to the target. Now let me explain what this A is. I copied this 2sum method from the solution of 3sum problem. In the solution to the 3sum problem, as we discussed earlier, we used to fix one number and then call the 2sum method. that one number is integer a. But for this solution, it's not going to be only one number that is fixed. Let's say for example k is 5. So when k is 5, we are going to fix one number and then give a recursive call such that k is now 4. Now inside that method, we are again going to fix one more number and make a recursive call with k equal to 3. And when k is equal to 3, again we are going to fix one number and make a recursive call with k equal to 2. And with k equal to 2, we can make a call to toSum method. So by the time the control reaches the toSum method, we would have already fixed 3 numbers from the array. So to have that flexibility of how many numbers that we have already fixed, we are going to use a vector or an array instead of a single number. So it would be a vector of integers and we can call it a. And because of that, this is going to change. Now earlier a was a single integer and we used to make an array of these 3 numbers. Instead of that, now there will be an array of all numbers that are there inside this a vector, and plus we will add these 2 numbers in the same. So we can get rid of this comment. Now create another vector of integers. We can call it a temporary vector which will be equal to a, and in that we will add 2 numbers. So temp.push back. It would be nums of start and nums of end. So let me add them one by one. So nums of start, nums of end, and now get rid of this inside array and instead have that temporary. This is the only change that we need to do in toSum method. Now let's move on to implement the find nSum method. Now just a quick reminder, for this toSum method to behave correctly and return the correct answer, the input array must be sorted, and hence we will sort that at the beginning. So sort this array, so arr.begin and arr.end. Once the array is sorted, we can call a generic nSum method which will find the number of ways in which k numbers can be chosen that add up to the target from the array. So nSum will take array as input, k as input, and the target as input. However, this is not sufficient because as we go deeper inside the recursion, we only want to choose the numbers from the part of the array, not the entire array. For example, let's say again k is 5. Initially, we will fix the first element and solve the four-sum problem in the remainder of the array. So that is from index 1 to n-1. Now, in the second iteration, when we have second element fixed, then we want to solve the four-sum problem on this part of the array, that is from index 2 to n-1, and so on. Hence, our method should take the indices, that is the part of the array, as input as well. And hence, we will have start and end indices. So start and end, and we'll declare those. So in start will, in the beginning, start will be from 0, and int end would be the last element. So that is arr.size -1. So now our method takes array, k, start, end, and the target as input. This nSum method finds all the ways in which k numbers from the array can be chosen so that they add up to the target, and that answer is in this ans variable that we have created. At the end, we don't need to return the answer entirely, we only need to return the size of the answer. Our nSum takes these 5 parameters, but these are not sufficient because in each recursive call we are fixing one number and then making a recursive call with the rest of the array. But where are we storing those fixed numbers? And to store those fixed numbers, we should have one more vector as a parameter. So we'll declare one vector. So vector of integers chosen, and initially it would be empty. We will pass that chosen to our nSum method as well. And now let's implement this nSum method, which is pretty straightforward. So int nSum, it takes vector of integers, and we can take this by reference because anyway we are not going to modify this. So arr integer k, indices int start index, int end, then integer target, and finally the chosen numbers. So vector of integers that are chosen. Alright, for any recursive method, the most important part is the base condition. So if k equal to 2, then we are going to call the toSum method. toSum which takes parameters as ARR, then start, then end, the target, and the chosen numbers. We don't need to pass the k here because we already know the k and we are calling the specific method toSum, and we can return from here. Now if k is not 2, in that case we are going to fix one number at a time and make a recursive call. So for int I equal to start, I less than or equal to end, and I equal to increment, which will take ARR as input and I as input. Just to remind you, increment method increments the I, but it also skips the duplicates. Now we are going to fix one number, that is ith number in each iteration. So int fixed is equal to ARR of I. Now this number is chosen, so we will add this into our chosen array. So chosen.push_back, and we will add this fixed number and make a recursive call. So nsum, it takes ARR as input, then k minus 1 because we have already fixed one number now. So k minus 1, start will become I plus 1 now. So end will be same, end, target will be target minus the fixed number because we have already chosen one number. So target has now reduced by that much. So target minus fixed, and the final vector is chosen. In the next iteration, we will choose the next I, but before that, we should remove the previously chosen number. So chosen.pop_back. Nsum method does not return anything, so my mistake. So it should have a void return type. Now just to add some robustness, we can handle the cases when k is less than 2. So if k is less than 2, we can maybe just not do anything. We can just return from this method for now. Now let's see if our solution works. Good, it works. Let's quickly take a look at the time and space complexity of our solution. This sorting method takes big O n log n time. This is a constant time step. This is also constant time, chosen constant time. Now we can check how much time does our nsum method take. The last step is of course constant time again. So the complexity of find nsum method depends on big O n log n and the time complexity of nsum method. For the nsum method, this base case checking will be constant time. Here it will be constant time, but toSum method, as we already know, it's a big O n time solution, and here it is going to run n times, and it is going to give the recursive call to the same method, which we don't know the time complexity of, and this is where the recurrence relations come into picture. But before that, let's quickly write the time complexities of the remaining steps. So constant time, popping is also constant time operation. And this is something that we don't know about again. We need to find the time complexity of recursive solutions using recurrence relation. Let's assume the time complexity of this solution is t of k. The time complexity depends on the parameter k, and hence I have k here. If the time complexity of this method is tk, then the time complexity of this step is going to be t of k minus, and we are going to call this method n number of times. So from this information we get the recurrence relation as tk will be equal to n times t of k minus 1, and because the rest of the steps are all constant time, so it would be big O 1. So big O 1 for the rest of the steps, and in addition to that we will have n times tk minus 1, and that will be equal to tk. Now this is the recurrence relation that we get for this nsum method. I'm going to make a separate video on how to find the time complexity from the recurrence relation, or how to find the time complexity of recursive solutions. But that will be a separate video, and hence I'm not going to go into details about how to solve this recurrence relation at this time. But in the meanwhile, you can definitely take a look at a blog post that I have already written that explains recurrence relations in fairly easy way and in fair amount of details. It should certainly get you started. Now here, I already know how to solve this recurrence relation, so I can just let you know about it. As we discussed, it's going to be big O n power k minus 1. And it's k minus 1 together, so I will put a bracket around it. I hope that you liked this problem and this video. Importantly, many people are afraid of recursion. I hope that this video helps you realize how intuitive the recursion is and how easy is it to use it in the real functions. As a quick reminder, I'm going to put the link to my blog post that explains the recurrence relations and how to find the time complexity of recurrence relations in the description below. So do check that out. If you enjoyed learning something new today, give this video a thumbs up and share it. Post any questions in the comments below so either I or someone from the community can respond. I would also love to hear any suggestions and feedback that you may have. Don't forget to subscribe to Interview Recipes. See you next time and bye for now.